All right, let's see. There is a coefficient of friction, of kinetic friction, of 0.15 between an 8-kilogram block of wood and the level floor. All the level floor, by the way, means that our force of friction is just going to be mu times m times g. Right, so it's going to be 0.15 times 8 times 9.8. So let's figure that out. 0.15 times 8 times 9.8. And that is 11.76. And that just opposes the slide. So let's see. Let's draw a picture of this. Here's this box. Let's see. It's there's a force of 9.2 newtons to the right. So let's draw that. 9.2 newtons, and the block is sliding to the right. Okay, what is the acceleration? Okay, so the applied force is going to be to the right. Notice that the friction force is actually bigger than that applied force. Since it's sliding to the right, that friction force is actually going to be to the left. So 11.76, this is our friction. Right, remember that opposes the slide. So if we're sliding to the right, the friction force is going to be to the left. Okay? Wink. And then, to the right is positive, to the left is negative. And then what is this, 8 kilograms? Okay, so in general with these, right, you've got plus or minus the applied force, right, plus or minus the force of friction equals m times plus or minus the acceleration, right, okay? And plus is to the right, minus is to the left. So let's fill this in. Let's fill in what we know. We know that the applied force is to the right, so positive 9.2. We know that the friction is to the left, so minus 11.76. And then that equals 8 times A, and we're going to find out what A is, right? It'll be plus or minus, right? Okay, so 9.2 minus the answer I just got. I get negative 2.56 is equal to 8A, right? So divide that by 8. And I get that the acceleration is negative 3.320 meters per second squared. Now, we have to decide, is this thing speeding up or slowing down? Two ways to do that. Notice that the velocity is positive, that we're sliding to the right. The acceleration is negative, right? So that means if they're in opposite directions, that means it's slowing down. Or decelerating. Okay, that's one way to do it. The other way to do it is to look at the forces. Notice it's sliding to the right, but the force to the right is smaller than the force to the left, so therefore it's slowing down. It's decelerating. Right? So we would say decelerating. Ta-da. Yeah? All right.